Hello, everybody. This is going to be the lecture video, or at least one of them, for Unit 2, where we will cover programming with numbers and strings. There's really a lot of important concepts to learn in this unit, and there's quite a list of reference topics, as you can see here. And because of that depth and complexity, this unit is going to stretch over 2 weeks. I am going to attempt to record a series of lecture videos, kind of breaking the topics into categories. You can still watch the older lecture videos that you see down here. These are kind of dated, but the material is still completely valid, and it walks through basically the same content from our old textbook, including examples. But as I mentioned, they are kind of dated. What I intend to do here is, because we're moving away from using a textbook, is I'm trying to cast it off completely and kind of get everybody into this mode of like being able to find these Python resources online, and W3 Schools is our primary reference site for this material. So what I'm going to attempt to do here is start talking about some of these concepts. Most of what I'm going to do is just look at the content and then the reference materials on W3 Schools and use their little try it editor to kind of demonstrate the ideas. So I'm not going to get into like necessarily coding some of this stuff, but that will be repeated when we do the exercises during class time. And of course, I do the Kahoots too, where we kind of reinforce those topics as well. I also have been working with the AI companion here in the Zoom recorder, and it kind of sort of generates lecture notes for me. And I've been kind of toying with kind of how to release those or include them, or if they're valuable or not. But long story short, I'm going to try to hit as many topics as I can in this video. I'll get it to a certain point, and I'll work on creating an additional one. Generally, and I say this to all my students, I try not to do this lecturing during class time because we only have 2 hours, and I prefer to use coding or do coding during that time frame. So I'm trying to get in this habit of pre-recording the lecture videos far enough in advance so that you guys can all benefit from them, and then always refer back to them as well. So once again, we're going to extend this material over 2 weeks, and there are a lot of little nuanced things to learn in this chapter, and not chapter, in this unit, and arguably maybe one of the more important units that we're going to go through, because it has so many fundamental concepts. For those that are completely brand new to programming, there's a whole bunch of things that you have to start wrapping your mind around to learn how to computer program. For those that are already experienced programmers and know other languages, chances are you can probably look at these reference materials really quickly and kind of get right to the exercises and try them, often guessing at the code and probably getting it right. And then you can just use this stuff here, all these links that I have as just reference, basically. For those that are new, though, I would encourage you real strongly to listen to this lecture and kind of follow along with me, maybe even visit the website as I'm visiting it, and maybe even try some of the examples. And then once again, when we get to the exercises, I will reinforce all the stuff that we're doing and demonstrate it in detail inside of an IDE, probably Spider. All right. Let's take ourselves now to the W3 Schools website, and I'm going to try to do this in a different browser so that I don't have to deal with a bunch of ads. So I'm going to just pause for a second here and turn on my Brave browser just a moment. All right, so I'm now inside my Brave browser, and once again, I use Brave. It's basically a clone of Chrome, so everything renders the same, but it has the built-in ad blocking, pop-up blocking, tracker blocking, and all that, and it blows away a lot of the ads that this site has, which I find very intrusive when I'm trying to teach, especially when they're are animated and colorful and stuff. All right, let's talk about this concept of variables. And variables are a thing that I usually use analogies to kind of explain to my students how they work. Basically, as they describe here, variables are containers for storing information, or data. Data can take a bunch of different formats, but whenever we create a variable in Python, really what we're doing is we're reserving a spot in memory on the computer. And when I say memory, in RAM, so random access memory, that's reserved to store something. That location is given a name, and then you can put stuff into that location, remove stuff, change stuff, delete it, etc. Sometimes I use the analogy of a box for a variable or a jar, for example, like I'll have a box and then I put stuff inside of it. And then when I want to go get that stuff, I just go to the box, open it up and pull it out, right? And do whatever I need to do with it. If you've learned other programming languages, you will know, for example, that most what we call formal old school languages, like let's say like Java or C or C++ or C Sharp or something like that, will have variables that enforce what we call data types. And data types means, for example, that in this container, I can only put words, or this container, I can only put certain types of numbers. And those traditional languages were very, very strict about it. And if you didn't follow their rules, things would break. Python, straight away from the beginning here, so you're aware of this, is what we call a language that is not strongly typed. In other words, you can put whatever you want in a variable. One moment it could be a number, next moment it could be words, next moment it could be some sort of complex data object. It really doesn't matter. Python doesn't care. It will take all of it and work with it just fine. That becomes uncomfortable for old school programmers, but for modern programs, it's kind of a gift because that's a stumbling block when you first start to learn. Also, when you're declaring a variable or setting one up, it doesn't have a special command for it. In other languages, we often have to have some sort of initiator or like have some declaration, like we say var, or we declare the data type and then give it a name and then give it a value. In Python, we simply come up with a name and assign something to the variable. So for example, on the screen right now, I have a variable named x, and then I use the equal sign, and then I'm placing in it the container named x. I'm placing the number 5 as a number into that container. With y, we're using that equal sign again, and this time we have a string. And we know it's a string because there's quotes around it, either single or double, doesn't matter, but it's a string of characters or a collection of characters, but they're words, basically. Now, if I put numbers inside those double quotes, that's treated as a string too. When I don't include the quotes, then it's treated as a number. In this case, this is a counting number, so we call that an integer. Once we place something in a container, we can see what's in the container by simply printing the variable name. So in other words, inside the print function's parentheses, we throw the variable name in and it'll throw it up on the screen. Sometimes it's really simple, like a number or some words, and sometimes it's a complex data object, in which case Python tries to render it in a way that makes sense for that object. But this is really a pretty simplistic thing. One thing to kind of wrap your head around right away is as we put values into a variable, right, a named variable like this, the equal sign in a programming language is not a mathematical operator. So we don't use the equal sign to do math. All right, and that gets a little bit confusing. What the equal sign really does for us is we actually call this an assignment operator, meaning that whatever, and this is my little mantra, whatever is on the right side of that equal sign, the number 5 in this case, gets stored in the variable on the left side. So it's a basically way of saying I'm taking the number 5 and I'm sticking it into X, or I'm taking the word John, sticking it into Y. Right. So that's kind of the basics of how to do that. Now, of course, if you hit the try it yourself editor on this and run it, print X will print 5 and print Y will print John. Pretty intuitive, really. They do start to talk about, the data types here, for example. And this is what we talk about strongly typed. If I was doing like Java, for example, and I put the number 4 into X, I couldn't then come along and store Sally in it. Python doesn't care, right? And that's weird. But Python can dynamically change data types for its variables, which is kind of both cool and uncool at the same time. It makes traditional programmers very uncomfortable. And usually, generally, right, like if I'm putting numbers into a variable, I'm not going to really switch it to a string. But there are circumstances where that could be useful. It's just extreme flexibility is what it is, basically. There's also this concept of casting. And we'll do a little bit of this because this becomes important, especially when we grab input from our users. So for example, casting is basically an approach to take one type of information and convert it to a different type so that it can be more properly processed. So for example, and this is where we use it a lot, is if I ask my user to enter their age as a number, right? Let's say it's 24, right? And type in 24, press enter, and it gets stored in a variable. If I want to do math with that number, I have to cast it. I have to convert it to a number. So this is a really weird phenomenon, but anything that we get from the user at the keyboard comes in as text. I can't do math on text, but I can do math on a number. So for example, if I ask the user to input the number 3, if I want to do math with it, I have to do this process, which is basically run the integer function to convert it to a number to store it so I can do math with it. Otherwise, if it comes in as a string with, basically with quotes around it, I can't. So that's the basic use of casting. And you can see the 3 different basic casting approaches are converting something to a string with str, converting something to an integer with int, or converting something to a floating point number where it has a decimal place in it, right? And sometimes there's little nuances, especially with numbers, like knowing when to have it an integer, when to have it a floating point, because it does affect mathematical operations. If you want to examine what type a variable is, and you don't know, you can basically run this type function inside of a print statement, and it will display some information. It'll tell you this is a float, this is an integer, this is a string, right? Or something else, if it is something else. So that's kind of a helpful little command. If you are working with strings, it really doesn't matter if you use double quotes or single quotes. Most programmers, I think, by default go to double quotes for strings, but there's a reason why it allows both. So for example, if you want to have a string that includes the word don't with an apostrophe in it, that's a single quote, you'd have to wrap double quotes around it, right? Or if you wanted to have a phrase where John said, double quote, this, undouble quote, right? You would put that whole statement if you want the double quotes to appear inside of single quotes. It allows a little bit of nesting of information. So it's just a flexibility thing. True for most languages, by the way. The variable names are case sensitive. So Python might not care about the data type of the variable information, but it does care about the name. So a variable named with the lowercase a is not the same as a variable named with an uppercase a. They are different variable altogether, right? So they make the point here that if I set a lowercase a to 4 here and then set uppercase a to Sally, Sally will not overwrite the lowercase a. Right? If this is a lowercase a, it would. Let's talk now a little bit about variable names. Variable names do have some rules. So in other words, when you're naming a variable, there's certain ways you can name it and certain ways you cannot. So these are the basic rules for Python. A variable name must start with a letter, or you can use an underscore. Right? And sometimes people use the underscore for certain types of programming. It cannot start with a number. All right, so you can't put a number as the first character in a variable name. A variable name can only contain alphanumeric characters and underscores, A through Z, 0 through 9, and underscore, and that's it. So you can't use pound size, exclamation points, or anything like that. The variable names are case sensitive. So they use the example here of age, and age, and there are all 3 different variables, right? So thinking about how you name stuff is kind of important. The other thing is that a variable cannot be any one of the Python keywords. And I'm just going to very quickly open this up in a new tab here. So Python has a bunch of words that it reserves for its internal language usage. Like these will be the ones that color code while you're coding. And here's, I don't know if this is a complete set of the reserved words, but it's a set of most of the popular ones. So you can't use any of these for variable names, basically. And I think there are more, but this is let's call it a simplistic list. But if you start to try to name something, the name of a function, it will yell at you, right? And it won't work, and you'll figure it out pretty quickly. What I would recommend here is when you are naming your variables that you do name them to be descriptive of what's inside them, right? And so if you're capturing somebody's first name, maybe you call it first name, that type of thing. Here's some examples of like different variable names that are all valid and legal. So you see all lowercase, underscores in between, what we call camel casing, where the second logical word starts with a capital. You can go all caps if you wish. Usually that's reserved for implied constants. We'll talk about that in a minute. But you can also include numbers as well. But whatever you name it, once again, if you ever come back and look at your code and go, what was I trying to do here? What is this? What you name something does become important because it's indicative of what it holds. And I think that's pretty important. Here's some examples of ones that are illegal. So for example, you cannot have a space in a variable name. That's not allowed. Right? You can't have a dash. The only special character that works is the underscore. And then you can't start with a number. So those are just kind of to remove that essential things. If you're using a variable name that's complex, in other words, you want to name it with multiple words, which I think is actually a really good habit because you can verbosely name an object and know exactly what it is. Instead of saying, interest rate for mortgage, don't just say int mort, that kind of thing. It's better to be more descriptive, and that's kind of a modern convention as well. Usually when people are doing multiple words in a variable name, they'll start with lowercase. Lowercase is kind of the standard convention, right? Not a rule, but a convention. And then whenever you hit a logical word, you use an uppercase, and they call that camel case. They also have Pascal case, basically the same thing, but it starts with a capital. And then they have snake case, which is separating logical words with underscores, and you can use any approach you want, right? And I kind of use a mix of those. I guess I tend to go camel case most of the time. So just be mindful of that, and I will play with all different approaches when we do our coding. Python is kind of weird because it has such weird, I guess, flexibility, and that's also one of those uncomfortable things for traditional programmers to learn. And here's one of the examples. Like, it's possible in Python, and I know other languages support this too, to declare three variables at once. Notice they're separated by commas, and then assign each one all at once. I'm assigning three variables here. It'd be kind of the same as saying X equals orange, Y equals banana, Z equals cherry, right? And so I think that's kind of neat. I usually don't do this, but it is possible, right? But I'm usually not very comfortable. Another thing is you can do weird statements like this, where I'm setting up three variables here. I'm making them all equal to each other, and ultimately the rightmost thing is what all of them will hold. So orange will go to Z, orange will go to Y, orange will go to X, and then all of those will be orange. Right? There are other more complex data structures such as lists and tuples and sets and dictionaries, which we will learn later. We're not going to touch this topic right now, so we'll stop pretty much right here for the moment in this category. All right, so when it comes time to see what's in a variable, and we saw this just a little while ago, you can just take, if a variable holds whatever it holds, we can just put it directly into a print statement and output it. Very handy, right? And sometimes when you're writing code, you forget what's in a variable because it's way somewhere else on your code, 1,000 lines up or something. So you do these commands just to see what's going on. So that's very, very helpful to kind of display it. You can, if you have multiple variables though, use the print command with what we call parameters or arguments, basically. So I can print all three of these at once, and I separate the variables with commas, and then as they print, a space will be placed in between each one of these. This one I'll demonstrate here, right? Because there's no extra spaces placed here, to separate out these words. But indeed, when you look over here, spaces are added. So this is kind of a parameter approach. Another thing that you can do with it is you can also kind of just brute force text into it like this. So you combine variables and text, and you'll see the output here in a second, even though it's kind of slowly cumbersome. And once again, for those of you used to other languages where you're concatenating text to variables, notice that this approach where we use, basically arguments or parameters we're throwing in here, separated by commas, forces an extra space in there and displays it on the screen. Just something to note. I'll demonstrate that as we code. If you do want to actually concatenate, and this is one of these words that we're going to kind of investigate here in just a second. Concatenate is a fancy programming term that basically means to join strings of text together into one string. Right? So I have this word, and this word, and I want to stick them all together. So let's come over here and just kind of take a really quick look here. If we concatenate these three words, I want you to notice that it prints out. But be mindful of the fact that in this situation, I have to force the space into that spot because I'm joining the strings and the space is part of it. The previous approach we used, because we were using the parameter approach, that introduces a space automatically. This approach does not. So like if I remove these spaces and then run this, all the words are smushed together because I'm literally taking the string as it is and joining it to the other string. So if I want spaces in there, I got to add the spaces, right? Another weird approach would be like I could brute force a space in like this, right? And I could copy that, I guess. And run it that way. And that's not quite as elegant, but it's doable, as you will see, right? So just be mindful of that little quirk or feature, right, when you're concatenating. When you are doing a print statement, and we did this in the Kahoot the other day, right? If I have two variables that are numbers and I put them in a print statement, this will actually output the math. If I were to put quotes around this like it's a string of text, watch what happens. It literally outputs that formula, so it's not doing the math. So just be mindful of that feature as well. It takes a little practice to get used to that one. You will also at times try to combine different variable types, and because this is not technically allowed, I can't necessarily join a string to a number. I would have to, and I'll show you this casting idea here, right? I try to run this. This is what we call a compile time error, like when we're running it, right? So you don't see the error. The code is not technically wrong, but the running it is, right? And it generates error because they can't join an int and a string together is what they're telling you. However, if I cast the number to a string like this, I can make it output the number 5 as a number 5, and it's not doing math. And yeah, that's not pretty looking because John is missing a space, but I can add the space there, I guess, to make it look whatever. And like that means anything. But just be mindful of that. So that's another use of the casting feature of Python. Another thing to be mindful of here, and we already talked about Python keywords that you can't use those for variable names, and here's a link to that same thing we were looking at, is this concept of a constant. So I'm going to actually go back here to, I don't know, it could be any one of these try it editors, I suppose. And this is kind of a weird thing because if we were like in Java or C# or something, and we were writing a value that's a variable, but we don't want that value to change. In other languages, we can actually add a keyword that forces that variable, once it's set with a value, that it can never change, right? And sometimes programmers like to do that. So for example, if you were writing a cash register program and you want to set the sales tax amount, right? That might be a constant value that really isn't going to change. Maybe once every 20 years or something it changes. And so they would hard code that, and then no programmer could make the mistake of changing the value. So like in Python, when I have like something that where I don't want the value to change, we can't really do it. Python does not allow this feature. So we do what we call implied constants. So I might like name this something like all uppercase, usually separating the words, doing the snake case thing with an underscore. And then not that this can't change, but we look at it and go, oh my God, that's something we shouldn't change. That's a value that we want to stick, right? So it's not enforced by the language, it's enforced by our convention. And that is also a convention in other programming languages to name what we call non-changing variable values, all uppercase. One of the reasons is why they're just really easy to spot in code, right? That's not a rule, and remember, it is a convention, but a lot of programmers do follow that convention. So I think it's kind of important to note. At this point, I think I'm going to end this video here, and I'm going to do this in chunks. So this is the end of part 1 for the lecture material, and then watch for the second video coming out soon. So this video ends here.